Hello, everyone. And again, I'm back with this very interesting question. Okay, so let's read the question here. A semicircle is inscribed in an isosceles triangle. So they're saying that this triangle, which I'm spotlighting here, is an isosceles triangle. And this is a semicircle, which is inscribed in it. Inscribed means it is closed by it. Okay, with the base 16. The base 16 is of this triangle. So let's say that this is base 16, which is from this end of to this end is 16, okay? And the height is 15. The height of the triangle is 15. Let's draw that height. The height has to be always perpendicular, a straight line. So let's say that this is height 15. Yeah. So yeah, this is 15. So that the diameter of the semicircle is contained in the base of the triangle as shown. Okay, so what's happening here is the diameter of the semicircle from here till here, which I'm going to mark in blue. Yeah, from here to here, this diameter is going to be of this semicircle, which is contained in the base. You can see that this diameter is the part of the base, which is 16. What is the radius of the semicircle? Okay, so we have to find out the radius of the semicircle. You should be knowing that the radius is half of the diameter always. And some kids may be prompted, with a less observation, they may just say, okay, it's a half of 16, which is 8. But no, remember, the diameter of the circle is from here to here, okay? But 16 is the space which is from here to here, okay? So there is a difference. This gap, we don't know how much is it on both sides, okay? So now, so we can't directly say that, okay, the diameter of the semicircle is 16, so the radius is 88. No, it doesn't work that way. Now let's see, how do we do this? As very smartly, we're going to solve this example with very, very less work and more of logical reasoning, okay? If you see, this is your height of the isosceles triangle. If it is height, it has to be vertical, perpendicular. So let's say that this is going to be a perpendicular angle here, perpendicular line. So that is 90 degree. And if you look at this half triangle here, only this half triangle, yeah? And there is this other half triangle, okay? Now what are we going to do is, let's find the area of this triangle first. So how do you find the area of the triangle? As simple as that. Area of the triangle, let's say that this is a triangle A, B, C. Yeah, so the area of triangle ABC is going to be base times height over 2. Am I correct? What is the base here? Base is 16, height is 15 over 2. And you can just simplify here. 2 8s are 16, so 15 times 8 is 120. So the area of the whole triangle, big triangle ABC, is going to be 120. Yeah. So this whole space, so this whole area of this triangle here is going to be 120. Now, they're not asking us to find out the area. They're asking us to find out what is the radius, this length or this length or this length. Or can you draw this line? Yeah. This is also a radius of this circle, isn't it? They're asking us to find out this radius. Yeah. Which is in green here. Or this could be this also till here. Or this could be from here to here. Okay. What is the radius? One of the theorems of the triangle is that, triangle and the circle, not triangle actually, circle, is that the tangent drawn outside to the circle always touches at one point. Do you see? This line, this side of the triangle is acting as a tangent to this circle. Yeah, can we take this as a tangent? And a tangent is always perpendicular to the radius. Okay, so this becomes a perpendicular line there. So we have just drawn one radius here, and we have taken this side as tangent to the circle. We know that the tangent and the radius are always perpendicular. Okay. Now, we know that the whole circle area is 120. Okay. And as this isosceles triangle, it is divided into two equal parts. So the area of the left is 60 and the area of the right is also 60. Do you both agree? We have divided the area into half. Now, can we again, let's mark this point as D here. Okay. Now, can we again look at only triangle ABD? Okay, let me write down that in triangle ABD, can we say that side AB could be your base and this, let me mark this as Y, okay? And your YD could be the height of this triangle. Yes or no? Yeah. And before that, let's say that your base is 16, so your BD is going to be half of that. So this part is going to be 8. Yeah, this part is going to be 8, which is length of BD. And we know the height already. We know the height already here, okay? We know the base half is this 8. One more thing, in triangle ABD, as we just said that we can take AB as a base and YD as a height, and we already know that the area is 60. Yeah, so can we use all that information and find out the radius? Yes, we can, and let's see how we're going to do that. But before we do that, we need to know what is the AB here, this side length AB. How do we find this? As we know that this is a right triangle again. Yeah, this is a right triangle again. We can use the Pythagorean theorem to find AB. So AB square is going to be 8 square plus 15 square, which is going to be 64 plus 225, which is going to be 289. Yeah, which is AB square. So your AB is going to be root of 289, which is going to be 17. So let's write down your AB 17 here. Okay, now coming back to this half triangle ABD, you know that AB 17, and you know that YD, we are taking it as a height, which is also the radius. So let's take the radius, and we want to find the radius, isn't it? So let's take the radius here as R. So can we say that in the triangle let's say triangle ABD, if you want to find out the area of that triangle, can we write it as a base AB times height, which is R, which is nothing but radius, by 2 equals to 60. We already know that the area of that half triangle is 60. So can we write it further that AB is 17, the radius is R, and this 2 goes to right side and becomes 120. And further, radius can be written as 120 over 17. So they should be the radius of your circle. Do we have that option here? Yes, you can see it here, which is option B. So let's mark it with some different color here, which we have not used before. Maroon, yeah. So option B, 120 over 17, is going to be the radius of that semicircle. All right. I hope you have understood this question. It's as simple as that. I'm just going to quickly review it. What you have done here is you're just going to find out the area of this whole triangle. As this is isosceles triangle, you split that area into two equal parts. Yeah. Now we know that the area of this part is 60. Also, we first found out this slanting side, which is the hypotenuse of the half triangle, which is 17, by using the Pythagorean theorem. And then what we did? We took this as a base and this as a height because we want to find a radius, and radius is nothing but height. It is here. So base 17 times radius R over 2 is going to be 60 because we already know that area is 60. And then you rearrange it and you find R is equal to 120 over 17. Okay, so if you want anything specific, any question you have, please do comment. and tell me, how did you understand this question? How is the way I'm explaining? Yeah. Thank you so much, guys. Jai Hind.